Welcome to this explainer. Whether you're a college student gearing up for exams or honestly just kind of curious about the everyday chemistry happening right under your nose, you are in the exact right place. Today, we're going to take a calm, deep dive into the silent, invisible power sources powering your study sessions, your calculators, and really, your life. We're talking about batteries, specifically the primary ones. Okay, let's dive into this and demystify the chemistry of portable power. So think about this. It's a completely normal part of our daily routine, right? Your phone dies, you plug it in, and boom, a few hours later, it's good to go again. But when the battery in your TV remote or maybe your wall clock finally gives out, well, you just have to toss it and buy a new one. Have you ever wondered why that is? Why can some devices drink from the fountain of youth while others are strictly one and done? Well, it all comes down to the fundamental classification of batteries. Now, you might be wondering, why does this actually matter to me? Well, beyond just passing a chemistry or engineering exam, understanding the difference between these types of batteries genuinely impacts your everyday life. Knowing how these little chemical factories work helps you make better choices, saving you money at the store and reducing environmental waste. It empowers you to actually understand the tools and gadgets you rely on every single day, rather than just treating them like mysterious black boxes. Okay, so let's look at the broad landscape here. In the world of commercial batteries, we basically have two main families. On one side, we've got primary batteries. These are your single-use guys. The chemical reactions inside them are totally irreversible. Once they're done, and you discard them. On the flip side, we have secondary batteries. These are the rechargeable ones, like the ones in your smartphone or your car, where you can actually force the chemical reaction to run backward just by plugging them in, which allows for multiple cycles. Today, though, our main focus is going to be squarely on that first group, the primary cells. Section 1, the nature of primary batteries, a one-way chemical street. So the absolutely crucial point here is this specific definition. A primary battery is an electrochemical cell where chemical energy is converted into electrical energy, but, and this is a big but, only as long as the chemical components inside are active. Once those active chemical ingredients are completely used up, the battery is dead. You literally cannot regenerate them. You cannot reuse them. Applying an external electrical current won't reverse the reaction. In fact, trying to force a recharge can actually be pretty dangerous. The energy is meant to flow outward and only outward. Section 2, the everyday companion, dry cells. You know, you have probably seen this 1,000 times. This is the classic dry cell, often called the Leclanche cell, named after its inventor, George Leclanche, way back in 1886. It's that standard AA or AAA battery you'd pop into a flashlight, a radio, or a portable tape recorder. Typically, this little cylinder generates about 1.5 volts of electrical potential. But what is actually happening inside this familiar container? Let's break down this discharge process. Instead of, a dense wall of textbook equations, think of it simply as ingredients that are just eager to combine to create power. First off, the outer zinc container acts as the anode, basically sacrificing its own electrons. Meanwhile, sitting right in the center, there's a cathode made of manganese dioxide, and it is absolutely eager to receive those electrons. Because the battery forces those electrons to travel through your device's circuit to get from the zinc over to the manganese dioxide, that flow is exactly what powers your gadget. Once the zinc is eaten away or the manganese dioxide is used up, the reaction stops. The one-way street reaches a dead end. Section 3. The tiny powerhouse, lithium cells. Now, lithium is fascinating because it's a super light metal with a high oxidation potential, which makes for just an incredible anode. These primary cells are incredibly lightweight, but they pack an exceptional energy density. Plus, because they use non-aqueous solvents instead of water-based electrolytes, they can operate reliably in crazy extreme temperatures. We're talking anywhere from 40 to 70 degrees Celsius. And perhaps most impressively, they have an incredible shelf life. You can literally leave one in a device for up to 10 years, and it's going to be ready to work when you need it. And that brings us to this very satisfying number, 4 volts. To put that into perspective, while our classic everyday dry cell maxes out at about 1.5 volts, a tiny lithium primary cell can push up to 4 volts. That is a massive difference in power output from a single compact unit. This high voltage and long-lasting reliability make them the absolute material of choice for things where failure simply isn't an option, like aerospace applications, military tech, and critical medical devices like neurostimulators. Section 4. A peaceful power takeaway. The most empowering thing about understanding the chemistry of primary batteries is that it allows you to match the power to the purpose. You really don't need a high-tech, expensive lithium cell to just run a simple wall clock. An inexpensive 1.5-volt Leclanche dry cell is perfectly suited for that low-drain task. But on the flip side, if you're designing a medical device or setting up a fixed voltage supply for a computer's memory backup that literally has to last for years without failing, you now know exactly why you must rely on the lithium cell. Understanding the tool means using the right tool for the job. There is a beautiful simplicity in primary batteries, isn't there? They basically give everything they have to light our way, and then they rest. Sometimes energy is meant to be spent just once, and that's perfectly okay. But it does leave you wondering, as our world pushes to make absolutely everything endlessly rechargeable, will there always be a place for the humble single-use battery? Thank you so much for joining me for this explainer today, and hey, good luck on your exams.